All right, guys, welcome to Chapter 7. This is Grizzly Risley back at it again, talking about exponent rules today. So, this chapter is not hard, but there are a lot of rules. So this video is super important to get all of the rules down so then we can practice in class. Okay, but first we need to figure out what is an exponent. And this says 2 and then a little 3, and I hope you guys know that that really means you're raising 2 to the third power. Okay, and then the big number, like the one that's physically bigger, the 2 is called the base, and the exponent or the power is the smaller number, which is the 3. And what it really means is repeated multiplication, 2 times itself 3 times. So 2 times 2 times 2. And the answer is 8. Not 6, 8. So 2 to the third power, 2 times 2 times 2. All right, let's get into our rules. So the first rule, what is a6 times a to the third? Okay, and then let me show you guys what it means first. So everybody makes 6 a's. A to the 6th means a times a times a times a 6 times. And then a to the third would be another 3 a's. A times a times a. All right, let me break it off here. Okay, so that's how you visually see a to the 6th times a to the third. How many a's do you guys see total? 1, 2, 3, 4, 5, 6 plus 1, 2, 3 is 9. So the answer is a to the 9th power. All right, so what's the rule? What's a shortcut so we don't have to do this? Well, you add 6 plus 3 to get 9. Okay, so our first rule, the product of powers rule, says to multiply powers that have the same base, you add the exponents. Okay, so I want you guys to try the simplify on your own. So feel free to pause it here. They're all b's, so we can use this rule. It's going to be b to the, now add all your powers. This is a secret 1 plus 5 plus 2. So b to the 8th. All right, on to rule 2. Now rule 2 says, what if you have a to the 4th power squared? So here's what that means visually. A to the 4th would mean a times a times a times a, 4 times. But then if you're squaring it, you're repeating those 4 a's again. So we got another set of 4 a's. A times a times a times a. How many a's do you guys now have total? 1, 2, 3, 4, 5, 6, 7, 8. So this answer is a to the 8th. Now what's the rule? How could we do this without having to draw it? When you guys have a power to a power, you multiply. 4 times 2 is 8. All right, so when raising a power to another power, you multiply. That's rule 2, multiply. All right, so why don't you guys try the example then? So we have m, and then if it's power to a power, you multiply, so m6. All right, on to rule 3. What if you have a bunch of stuff with a all raised to a power? Okay, so I don't think I want to draw this one out. This one you just distribute. And when you distribute, it's power to a power, so it's going to be this rule 2 again. So power to a power you multiply, so it'd be a6, b9. Right? 2 times 3 is 6, 3 times 3 is 9. This is really just rule 2, but when you have to distribute it to more than one thing. Okay, so to find a power of a product, you distribute, okay, I'm having issues here. Distribute the power to each constant or variable. Okay, so you guys can try the simplify. Again, we're just going to distribute. And when you have a power to a power, you multiply. So it would be Z16P6. That's rule 3. That's just like rule 2. All right, flipping over to rule 4. This is everybody's favorite. Anything to the 0 power is always 1. And if you don't believe me, type it in your calculator. Anything to the 0 power is always 1. So your example, anything to the 0 power is always 1. Okay, done. That's an easy one, rule 4. All right, rule 5 says, if you are dividing powers, what do you do? Okay, and I have a visual here. So A7 would be 7 A's. And then we're dividing it by a to the second, which would be 2 A's. So it looks like we can cancel. Maybe we can cancel one pair of A's here and one pair of A's here. And how many A's are left? 1, 2, 3, 4, 5. So this answer is actually a to the 5th. Now, without having to draw that representation, do you guys see what the rule is? You subtract. 7 minus 2 is 5. Okay, so that brings us to rule 5. When you are dividing powers with the same base, you subtract the exponents. All right, so you guys can try the simplify. If it's V and V, it's going to be V. And then the powers, when you divide, you subtract. So 8 minus 3 is 5. So V5. All right, on to negative powers. Okay, you guys know that Snoop Dogg song, if something, drop it like it's hot, drop it like it's hot. You know that song? So that's this rule. If your exponent's negative, drop it like it's hot. Okay, if your exponent's negative, drop it like it's hot. So here's what happens. If you guys have a negative exponent, you need to drop it to the denominator. And when you do that, it actually becomes positive. So the 7's going to stay, but the K3 is going to drop. And when you drop it, it becomes positive. Oh, and the variable and the power always have to travel together. So 7 over K3. Now the flip side of that, if it's negative on the bottom, then you bring it to the top. Bring it to the top. Bring it to the top. Okay, so this one, everything stays put, 13P and 4, but the M5, we're going to bring it to the top, and when you move it, it becomes positive. Okay, so if you guys try the example, it looks like the B negative 6 is going to have to drop, and the C negative 5, we're going to have to bring it to the top. Everything else stays put. So the 2 stays, the A4 stays, but the negative B will drop, and when you drop, it becomes positive, and the negative C will bring it to the top, and it will become positive as well. So there's no negative exponents in your final answer. Okay, that's rule 6. And then lastly, rule 7. When your base is negative, if the power is even, the negative goes away. The negative goes away. But if the power is odd, then the negative stays. Okay, and the reason being, if you square something, you're multiplying it twice. But a negative times a negative goes away and becomes positive. But if your exponent is odd, like 3, that means you're multiplying -4 3 times. And a negative times a negative times a negative, it will stay. So -4 to the third power, that's -64. Okay, so I think you guys knew that rule. So even power negative goes away, odd power negative stays. Guys, I know this was a lot, but we wanted to get all the rules out there so we can just practice. All right, thanks for watching. Grizzly Rizzly out.